Welcome to Tech Talk Thursday, Season 3, Episode 5. My guests today are Michael Ford from Aegis Corporation and Radu Diaconescu from SIO in Switzerland. They are at the forefront of the new IPC Cybersecurity standard, IPC 1792, and they're here to talk about security and the very real threats facing our industry at every level. So, welcome to Tech Talk Thursday, Season 3, Episode 5. The electronics manufacturing world is experiencing an explosion of technologies and demands, ranging from new products and applications to new technologies such as digital twin, autonomous robots, and AI. At the heart of all of this is the question of security and the very real threats facing our industry at every level. Here to discuss these issues today are Michael Ford and Radu Diaconescu, who are leading the charge with the forthcoming IPC 1792 cybersecurity standards. So, welcome, gentlemen. Thank you for joining us today.
Thank you very much.
Okay, nice to see you. So, let's get started and tell us a little bit about what are the cybersecurity threats associated with electronics manufacturing, and why has this suddenly become the focus of attention?
Thank you very much, Trevor. So I think the main difference between electronics manufacturing or any other manufacturing operation for that matter and a normal cybersecurity type of activity or cybersecurity protection is the fact that in electronics manufacturing you're not dealing just with your data. So as a company, as an EMS or as a contract manufacturer, you of course have to protect your data. But when you're producing, you also have to protect your customers' data. So there are several emerging risks that range from IP theft. So whenever you're dealing with design files, with products that are being manufactured, then you also have to protect your client's IP. On the other hand, I think we've all seen in the past year or even recently in the past weeks that there are some ways of altering products without the knowledge of the owner. So this is called supply chain injection. And I think people start realizing that this is more common than we previously thought, in the sense that there are malicious actors, there are bad actors out there that manage to change end products without the knowledge of the manufacturer, without the knowledge of the client, and without the knowledge of the user. This can lead to several problems in the field and several cybersecurity risks once those products are in operation.
Right. So when you're saying you're calling it a supply chain injection, are you talking about situations like the recent Supermicro example that was reported on Bloomberg recently, talking about the malicious malware basically that was injected into their computers that were being used in government applications in the US?
That would be one example, but I'm sure we're not hearing the full extent of it, and I'm sure there are several other cases that they're either under investigation or we're just not aware of them. And it can be something as simple as implanting a chip and sniffing out data. And it can be even more, it can get to something that is more threatening, where you kind of have like an active type of attack, where the product not only sniffs data, but is also able to behave in a malicious way. So think of all the autonomous cars that we have right now. We don't have right now, but we're working to have. Think of all the other products, and think of the possibility of having a product that was designed for one purpose behave in the completely opposite way. Yeah.
Yeah, I mean, Michael, I mean, one of the issues here, of course, is this is not just, we're not just talking about industrial equipment and professional equipment, where one of the biggest issues is with consumer equipment, because a lot of these IoT devices that you've got in your home have got very poor security attached to them. One example I heard recently, of course, was the Roomba uh, uh, cleaner that goes around your house. This engineer in Taiwan bought one and took it apart and found there was some device in there that was going around, and every Wi-Fi connected or Bluetooth connected device in his home was sucking up the information and sending it to somewhere in China. So, I mean, this is what we're up against, though. I mean, and as I say, one of the biggest threats surely is with consumer
Yeah,
products.
I kind of like this kind of smart technology, and I was, going to buy like Wi-Fi switches, to turn lights off remotely and all this other kind of smart tech. But when I looked into buying it, it wasn't just that you controlled it with your internal Wi-Fi in your house. You had to sign up to some web-based service. And to be honest, that isn't
Yeah.
really necessary. You've got to wonder how much information is being sent out from our smart devices into these kind of websites overseas, and how much that says about you as a person. For example, if you get to the evening and you don't see the lights go on, does that mean you're a target for somebody to go around and help themselves to your household contents? It reveals a lot about our habits, about who's in the house and what they're doing. And this can be, quite useful information for people. But you could also have the scenario where you want to make a cyber attack on a power grid. I mean, do you go for the very high security controllers in the power station? Or do you go and just simply turn everybody's stuff on at the same time and cause a power outage? I mean, we've seen that happen in Dallas this week, where you just simply overload the power grid and everything shuts off for days. That's an ideal time to start to do nefarious things. So in all of these
Yes.
devices, we've got to be so careful, because it's not just enough to put a firewall into place. You've got to be aware that at each stage of manufacturing, and even in the design, you are beginning to inherit all of the risks associated with that prior stage of the materials and the production. So yeah, it's true. Even the most modest of devices in your home, the smart home, all the way up to these driverless cars, it all needs to be secured in a much, much better way than it is today.
Absolutely, absolutely. So, we've all identified that there's multiple threats out there. So what can we do about it? I mean, you guys are working on this IPC 1792 cybersecurity standard. What's involved in that, and how do you think this will help to reduce or even eradicate this problem?
So first of all, I think we need to take a deep breath and realize that this is real and this is happening. So IPC is proactively working and it's developing this standard 1792, which is under work, and I think it's going to be developed. It's going to be published towards the end of this year. And what this standard tries to establish is essentially, it has two pillars, right? So one is sort of a cybersecurity label for manufacturing facilities. So essentially trying to determine the total value of the data that is being managed by a certain facility and the risks associated with it. So then there are going to be several conditions that depending on the data that you are processing, so essentially if you are manufacturing that is using highly sensitive data, then the requirements, the cybersecurity requirements would be more stringent. And then there's going to be that label put in place that will establish procedures on how to detect, so definitions of a cybersecurity incident, how to report it, potentially how to patch it, and it will provide guidance to manufacturers on how to increase their cybersecurity levels. and cybersecurity protection. And on the other hand, the second pillar would be kind of like a digital certificate that will travel with the product along the supply chain, saying that this product has been manufactured in a cyber secure location, and there wasn't any known incident that affected this product. And what is interesting is that we're trying to build the feedback loop and the mechanism to say, even post factum, to come back and say, look, there was an incident. We found out later that we did in fact have an incident, and that affected certain products. And then we're kind of like updating that certificate. And this is where also traceability comes into place, in order to be able to pinpoint exactly the products that were affected and take corrective measures in a timely manner.
Right. So, I mean, a lot of this is going to obviously depend on Chinese component manufacturers signing up to this and agreeing to be part of this scheme, which I assume is going to be driven by the big box builders who buy their product. Yeah, so the certificate, just to be clear, works on a blockchain system, so that it can't be tampered with during at any point along the supply chain. Is that correct?
So it won't be possible to be tampered with. It will be possible for the right people, the people that have the knowledge to update it, right? So it's not tampering it. It's exactly what I said, being able to come back and update that certificate along the way. So if there's a cybersecurity that has affected that product, we're flagging that. So it's kind of like the product traveling in the supply chain with a flag saying, yes, I'm fine. And then if it's not fine, then the flag turns yellow, right? So now we know what product is, and then we need to recall it.
Yeah, there are, I mean, just the mention of the word blockchain makes everybody feel either good or bad, I'm not sure. But people need to understand that blockchain is just one piece of technology that in itself actually does nothing. Because the purpose of blockchain is simply to secure data, to make sure that data is not tampered with. It's got nothing to do with the physical world, unless it is tied by what they call a crypto anchor. It means just the association of an immutable ID of some form of material or product. And then the record of that is stored securely in the digital world. And that blockchain is making sure the data cannot be changed, and therefore, and if the product itself were changed, like the ID was changed or missing, that it would show up. So, for example, in a traditional world, if you're making a good intrusion into the supply chain, you wouldn't just necessarily change the material. You would have to arrange for the material ID to be changed, or new box or new packaging. There'd be something that would be different there. Maybe you'd even have to change the design data. This was the Supermicro case, for example, where the bill of materials was adjusted and the design was adjusted such that you had this spy chip on the motherboard. So there is a kind of combination now in the modern cyber attacks, that it's not just physical and it's not just cyber, it's a combination of the two. And this is where blockchain is so important, because it enables you to make sure that the relationship is maintained throughout that chain that Radu was talking about. So this is where we kind of see the introduction of quite a few new technologies in the area, which Radu is quite an expert at, which really are going to change the way in which we approach security. You know, it's no longer the case where you can think that your firewall around your manufacturing site is enough. It's not. Because what about the design data that's coming in? That's an inherited risk. How do you know it's the actual design data you want? How can we get that from design into manufacturing? And that's another thing that IPC is looking at. Maybe use the security of CFX to transfer the design data across the network, or at least facilitate it, and then send it even directly down to the machine, as we're seeing a lot of machine vendors use that design data directly. So it's got to be absolutely right. It's got to be secure. And then, of course, you've got the product going out of the factory. But it's not just the product, it's the data going out of the factory. You know, my analytics, my business case, my market, my customers, my supply chain. That's gold in terms of value for somebody to understand that information, like a competitor. So, we're seeing a lot of
Hmm.
different kind of threats, which we want to be able to address within one set of IPC standards that will provide the guidance for people to understand what steps they have to do. We can't tell them the ultimate answer because there are so many cybersecurity companies out there with lots of great technologies. The problem is, which one do I need?
Hmm.
How do I use it? And that's where the standards come in to provide that guidance.
Yeah, I think the inertia really has to come from the OEMs themselves. They have to specify that it has to be their products need to be manufactured to this IPC standard, and then the manufacturers have to adopt it and implement it, etc. But I mean, the initial request has to come from the customer,
Hmm.
has to come from the OEM. So yeah, it's a really interesting area. So where are you on this journey at the moment? I mean, how far are you down the road towards actually producing uh, some standard that would address this issue?
There are a couple of different things going on. There's the cybersecurity standard that a committee was already established some time ago. We're helping out with that, and as Radu said, that'll come sometime toward the end of the year. Also, on the material side, we are looking at component authentication. For example,
Hmm.
let me just give you a quick use case here. Let's say you got into your car and you want to
Yeah.
make sure that everything in that car is sound. Now, the standards are going to tell you about the identifier of all of the key semiconductors. So there is a process that can register the ID of a semiconductor at the time it's manufactured, actually on the wafer. And that unique electronic
Hmm.
ID will then survive all the way through its association onto a circuit board, and then the circuit board inside a car controller, and then ultimately into the car itself. So there is then a way of being able to check that that ID has been preserved, that you can go into this blockchain environment, check out all of the associations, and be sure that that is the genuine part. That's a simple case. The more complex case is,
Right.
how do we
Right.
protect the whole car itself? And this is where we use the standards. This is not where we are making the standards. So applications and solutions will come along that will say, right, I've got 20 controllers in this car. I understand that there are certain activities and certain principles that I can start to measure so that when you start the car, I can energize circuits. There can be circuits talking to each other. There can be exchange of secure information. We can check the IDs. And that kind of self-security test is generating a digital fingerprint of that car. So that if anybody had come along and
Hmm.
changed a chip or altered the software or done anything in any way to create like a backdoor or something like that, that kind of self-test would then indicate, okay, there's a discrepancy here between what I see in the car and what I have on my blockchain storage. So therefore, I don't know where the problem came from, but I know that there's a problem, and I'm not going to let you get onto that highway. You then start to use the
Right.
traceability data to find out, okay, what is wrong, why it is wrong, who has the responsibility. So that's the kind of thing. So the development of these applications is a key part. The problem is that until you have standards, everybody's doing this in parallel and everybody's doing it in a different way. It's not interoperable. So we're all
Yeah.
paying for the same
Yeah.
development over and over and over and over again with every product that we buy. And we don't want to see prices increase for products simply because there are a few bad actors out there who want to take advantage of us. What we really need is a standards-based infrastructure so that we can be clever about making these algorithms and these solutions, these fingerprint generators. And so all of that can be done with very, well, relatively little cost. So we're solving a big problem with a very small cost.
Right. And of course, as you mentioned earlier, the traceability part is huge, the aspect of that. And the other thing is, of course, if you have one standard, it's a sort of level playing field. It's not, as you say, all these disparate systems working at different parts of the supply chain, which in itself would leave some gaps for people to jump in and take advantage of. Okay. Let's see. what role does emerging technologies? Oh, I've already mentioned the blockchain. So one of the big issues that is coming down the pipe, of course, is electric vehicles. It's going to be it's a huge industry and it's growing very, very quickly. And it's been accelerated by even some governments mandating that all the combustion engines have to be gone by 2030, which is
Yeah.
literally just round the corner. Um, so what sort of challenges is electric vehicles themselves going to bring in mitigating the cybersecurity risk?
Yeah, so as Michael said earlier, so we both like also worked on the development of the 1782A standard. So we both come also from the traceability point of view, and traceability tells part of the story. Traceability tells the story that you need to hear, right? But then there's a lot of missing information out there. So in the context of electric vehicles, I think there is a very big need to build that product provenance tree, essentially making sure that at each step of assembly we're not losing information. So we have a chip that goes on the board, that goes in a mechanical assembly, that goes in another sub-assembly somewhere in a different part of the world. Then it travels, and then it's being installed in an electric vehicle that then travels for a few miles, and then that sub-assembly needs to be changed, needs to be repaired. Right? So we're putting a different sub-assembly now. And we need to make sure that tree is then updated. So that product provenance tree, essentially the link between product IDs, whenever you have a servicing, whenever you have maintenance in the field, we're not losing the data. We're not just creating black holes of data where we don't know. I mean, it all looks good for the new vehicle, but then somebody changes something, and then suddenly, well, we have no idea what's inside.
Yeah. So what you're saying is really that there should be a provenance tree for each that goes along with the vehicle, so that if you change out a module for a new accelerator module or a new gearbox module or something like that, that module or the identifier for that module is updated in the provenance tree of the car, of the vehicle.
Let me just add, I mean, for me, automotive is a very, very critical sector of the industry because nowhere else has the requirement for such high security and high safety, and yet is such a competitive area on cost. I mean, we've seen with the recent issues with semiconductor supply, it was automotive who did not have the kind of commitment on buying power with the semiconductors, and they are the ones who ran into trouble first.
Yeah.
This is indicative of the industry as a whole. They don't want to waste cost. They don't want to spend money at all. And it's difficult to understand now that whereas the car used to just have a couple of electronic systems, the electronic vehicle, a lot of the electronics in there is simply there to protect the battery, to make sure that all the conditions are good for charging and discharging and use, etc. It's now more safety critical than it's ever been. It's just
It's still a relatively new area for them. I mean, because let's remember. I mean, it used to be that the automotive industry was always the slowest adopter of new electronic technology for many years, and then suddenly, in the last 10 years, have accelerated at a heck of a rate. And these guys are used to building cars using heavy engineering for combustion engines, that sort of thing. They're now building electric cars, so they're becoming an EMS company, in many ways, a big EMS company, of course, but they're assembling electronics, and it's a different ball game. It's different skills required, different
different
standards,
technologies
etc.
completely. I mean, you look at the old existing for many years car manufacturing environment, And then you look at the new entrants into the market. I mean, there are so many new companies now making electric cars. I mean, Tesla is the kind of headline act, as it were. But these are new companies and they're not following
Right.
old rules. And this is really good to see because the old rules need to be thrown away if you're going to keep pace
Mhm.
with the way technology is going. And so I think in electronics manufacturing
Right.
per se, we've dealt with this complexity and we're addressing the issues. We are actually, I feel, in control. I mean, I'd like to be a little faster, but okay, we're in control. But within automotive, I think they're going to be caught off guard. And unless they really start to look at more modern solutions and modern technologies, and you understand that they're going to have to change their paradigm for how manufacturing works, they're going to be in real trouble. And real trouble means that the new companies coming in are going to take advantage and really have a much better business case and a safety record digitally. And therefore, there's a challenge to their business. So I would really encourage that people do look at the automotive sector. And we don't want it to be, as you said, the ones who are adopting things last. I would like to see them in the lead, but they need to have some kind of push to
Yes.
do that. And I hope that push comes through.
And one other area of security from around manufacturing is, of course, in the military sphere. And over in the United States recently, they introduced the CMMC regulations. They're very stringent. They're designed essentially around this problem that we're discussing today, but they involve manufacturing companies to be qualified with an auditor literally visiting the factory and doing an extensive audit of all digital equipment in there to make sure that it's not it doesn't have any hasn't been infiltrated, it's sound, etc. Um, that's probably taking it to one extreme. But using your digital certification that you're talking about, is that going to be sufficient to try and keep out these bad actors?
Look, I think nothing is sufficient overall. I think that if we try as an industry to get to a point where we say, yeah, okay, now it's sufficient, I've done everything, I can rest for 2 years, then that's part of the problem. So it's always a race. So it's always trying to be ahead of the game. It's always trying to be proactive and finding new ways. What those digital certificates do very well is they align the incentives. It's something that we've been talking about also in the traceability part of it. We need to make sure that incentives are aligned across the supply chain, and we need to make sure that those bad actors have less of a financial incentive to do supply chain injection or to do anything else. And then on the other hand, it's easier to discover them, and we have a procedure to, like, whenever there's something discovered, we can pinpoint, we can find out what has happened, and we can trace it back to the origin of the supply chain attack. But I think having there's always going to be a risk. It's never going to be 0% risk, and people need to be aware of that.
Yeah,
I think it's going to be a bit like paying your taxes. If you've got a if you've got a lot of money, you've got a very expensive accountant there that's finding all the loopholes in the tax code. The government brings out new tax codes and he finds ways around them. It's going to be the same in the security business. There's going to be always somebody trying to find
yeah.
a way
The thing
around it.
is, with this CMMC, it's purely for US defense, and therefore, why should people be bothered? But I think that due to the stories that we've seen going back to the Supermicro case, etc., people are wanting to have guidance on what they need to do. And so this kind of check is really going to become necessary and widespread. People are already looking at applying CMMC in other areas. This is a nightmare for manufacturing
Right.
because they have no clue today of how to go about this. And you end up in a scenario, it's just like when the initial, quality and conformance standards came out. You start writing checks to get a signature and a tick in the box for some kind of, passing some kind of audit. But the real answer has to be a systemic approach where we control the security at all stages of the supply chain, and we know that we're doing things in conformance, so that we don't have additional cost, we don't have additional risk, but we do know that we're satisfying the needs for the secure environment. And so this is where we need to, again, helped by the standards, but be able to have the understanding of exactly what is necessary, what is not necessary. We don't want to waste money on solutions which are needless, but we also need to be sure that we can, counter the key risks and elements that we see and progressively go forward from there. So it may be at different levels, as Radu said. There is always going to be some kind of doubt somewhere. But you start at level 1, for example, basic kind of security and understanding that everything is secure, but then you go up level 2, level 3, level 4, until you're getting to a state where you're absolutely paranoid about it and nothing can go wrong. But throughout all of that, there needs to be an infrastructure, there needs to be an easy way of doing things that does not require immense investment in consultants coming in and having to check everything over and over again every single time, because that is not the way to go forward in the industry.
Right. Well, you see, on the one side of standards and things like that, you have you have to get. I'm going to have to edit this bit out, but on the one hand, you've got standards, but on the other hand, you have implementation of these standards, and as we found out in the European Union, there's all different ways of implementing rules, regulations, and standards, which are generally, in the case of the European Union, administered by the member country. And each member country can have a different level of implementation, as it were. Looking at the electronics global supply chain, there's a lot of talk at the moment about splitting that up and having, there's a big drive in Washington for revenue to help build more fabs in the United States. I think there should be the same going on here in Europe. And we know that obviously that China's trying to put a lot of pressure on Taiwan, primarily because of TSMC and other things. So all of this is going to change the dynamic as well. If you start getting more of the actual raw materials and components coming from each regional area, like fabs in Europe or fabs in the United States again. What's your view on that?
That's the real issue here, is that everything is international and everything is global. Just taking a car, for example, it's not one car factory. You have the end assembly in one point. You have in numerous different subcontractors everywhere around the world. Where are the batteries made? Where are the chemicals coming from? Those different elements are being put together. It's a truly global operation. So how are we supposed to be able to have a clear path of visibility if the rules and regulations are different in each country? Are we supposed to take the highest common standard and say, well, okay, if the target country requires this, therefore we need to require that in the source country? Or is it the source country rules that win and say, well, look, this has been manufactured according to our rules, therefore you can use it wherever you like? There's going to be a lot of argument about that. And so the discussions that we need to have must not be on a company-to-company proprietary basis. We've seen already certain companies working with other companies to achieve something which is admirable. But we need to talk about the industry as a whole, and that is truly an international issue. So we need to make that very, very clear that we start with some kind of understanding. Maybe it's created through the use of standards, and that just gets us 5%, 10% of the way there. We then need to look at solutions that are made by each of these different areas of supply chain, component manufacture, assembly, and into the market itself. There is a huge amount of work to be done there, and everybody needs to be working together because we need this through transparency throughout the whole thing. And so we're not talking about something that's insignificant here and we can turn around in 6 months or a year. This is something where we all need to work together across the whole world over the next 3 to 5 years and hope that nothing bad happens in that time. Hope that we can get to an answer before we get to a real serious problem.
Yeah, I mean, I think we're actually quite fortunate because the era in which we live in, pandemics aside, is one of great technological advancements. So now we have, and every year there's like new technology coming in that can help us solve several issues. And I think one of the, like when we're talking about the global supply chain, what we're trying to do is we're trying kind of like to switch the perspective and and um, and focus on the product. So yes, there are several standards that operate in different countries, but what if we could assign to each product, each individual product, we could assign proofs that it was manufactured in a certain location, it was manufactured in a certain way. Make sure that that data is private, but we can verify some claims. So we can say that whenever there's a product that is coming to me and I'm interested that it's manufactured according to the standard that I communicated to the manufacturer, then I can verify this, and I can verify this two tiers back as well. Like I sell this to my client, and my client sells this to the OEM. They can verify that things, they could potentially verify that things happened as they intended. Geography aside, if we have some trade restrictions, or if we have some manufacturing locations that are preferred, then we can use those. But I think that yeah, as I said earlier, we're fortunate enough to live in this era of technological advancement, and we're fortunate enough to live in a truly global supply chain. And I think this is truly for the best.
Absolutely.
We just need to manage it properly.
Absolutely. You know, it's a fascinating debate, guys, and it's a huge area, and it's not going to be solved overnight. But I have to say the work that you're both doing on this is fantastic and very much needed. So I want to thank you both for coming in and telling us all about it
Okay,
today.
thank you very much indeed for having us.